First, we broke the landing pad into its different components: the container, the materials we are going to use in the landing pad, and the arrangement of the materials. For the container part, we simply took the cover of the box used to store the A4 papers. The length and breadth of the box was 30 centimeters or below, which met the requirements in terms of measurement. However, the height was about 9 centimeters, which was more than 5 centimeters. Hence, with the use of a scissor and penknife, we reduced the height to exactly 5 centimeters. Next, for the materials, we first used dry sponges and dry cotton, placing the dry sponge on top of the dry cotton in the landing pad. However, when we dropped the egg down, the egg rebounded and fell on the ground outside, causing it to crack. The rebound effect was because of the air spaces in between the sponge and the fluffiness of the dry cotton, causing the egg to rebound when dropped from 2 m height. Hence, we removed the sponge and used wet cotton only instead. However, it was also a failure as the wetness made the cotton too hard for the landing egg, causing it to crack in the landing pad itself. In order to solve this problem, we placed dry tissue and dry cotton under the wet cotton. Thus, the arrangement would be dry tissue, then dry cotton on top, then wet cotton. On top of that, we placed dry tissue, and sprayed some water on top. It was a success. This was because the wet tissue and wet cotton prevented the egg from rebounding. Also, the dry tissue and dry cotton below the wet ones were fluffy, causing the egg to slowly sink to the bottom of the landing pad when dropped. This can be seen by the depression created by the egg when dropped on the landing pad. During the trials, we used a single thin layer that was wrapped around the egg in order to prevent it from splitting the yolk all over the place, damaging the landing pad.
Go.
We used the tracker software to create point masses to locate the egg, and thus using the different points to plot the velocity, displacement and acceleration time graphs of the falling egg. A calibration stick of 200 centimeters or 2 meters, between the egg and the landing pad was also used to represent the scale of the video. From the displacement time graph, we can see that the curve decreases and its gradient gets steeper. This means that the velocity is increasing, causing the steeper curve. A distance of 2 meters was displaced in merely 1 second. As for the velocity time graph, the egg was dropped at a height of 2 meters, and as it was dropped, its velocity increased uniformly due to the constant gravitational force exerted on it, which is why the line is a constant one, showing a constant acceleration, until 0.6 s as the gradient of a velocity time graph shows acceleration. Theoretically, as for the acceleration time graph, the acceleration was constant until 0.6 seconds, as the egg was experiencing a constant acceleration. However, the graph on acceleration time graph was jagged and inconsistent, as the egg had experienced air resistance. It also bounced off the egg pad, causing it to also experience acceleration on its bounce. Finally, from the acceleration graph, results were largely inaccurate due to air resistance. As for the tennis ball, according to its displacement time graph, the gradient of the curve gets steeper and steeper, under the force of gravity, falling 2 meters in 0.65 seconds. Then, in the next 0.55 s, the ball returned to its origin, which is the hand, by rebounding. Its velocity decreased due to the force of gravity, until it finally slows to a stop and the cycle hence repeats itself. In terms of speed, the tennis increased its speed at a constant rate upon releasing from the hand due to the constant acceleration of gravity. Then its speed suddenly decreased to 0 m/s when it hit the ground. since according to Newton's third law, every action has an equal and opposite reaction. The ball having pushed against the ground pushed the ball back up, thereby increasing its speed, but soon after, due to the presence of gravity acting on the ball, its speed began to decrease until it became temporarily stationary. Finally, the cycle repeats itself. Lastly, the acceleration time graph was again not very reliable due to the presence of air resistance, which made the overall motion of the ball extremely unpredictable. Lastly, we believe throughout this task, we have acquired the skill to inquire, the ability to design prototype product to achieve intended purpose, and also improved on our teamwork and movie-making skills. Thank you.